What is linear probabilistic modeling, or LPM? LPM is a model used to estimate the probability of binary outcomes through the use of linear regression. In other words, when situations can only result in two outcomes, we can use LPM to estimate the probability of those outcomes happening given an independent variable. We can get results such as accept or deny. At the doctor's office, you might see positive or negative test results. You might say yes or no. And in engineering, we commonly see success versus failure in a lot of projects. LPM uses linear regression in order to create a probability model. In this example, I have plotted random points and created a best line of fit. Now, as you can see here, each point has a certain amount of error from the best line of fit. And in order to account for those errors, another method called the ordinary least squares is used to create this regressed line. In the unique case of LPM, the expected value of y can only be 0 or 1, and we'll explore that a little more in the next example. Let's say that you are an engineer at a manufacturing plant for rubber ducks. You might want to look at several factors that might lead to the production of failed or defective ducts. You might look for factors such as the concentration of material, the age of the machine, the humidity, but today we're going to look at how temperature may affect production. Now here is a distribution of rubber duck batch failure. At the endpoints, you might notice that some of the points are a little more bunched up than the others. This may be a visual indicator of how your independent variable, in this case temperature, may affect your dependent expected value of probability, in this case failure. Now let's use this example to explain some of the problems that come with LPM. The most obvious flaw of LPM can be seen right at the endpoints of this graph. You can see that you can actually produce probabilities under 0 and above 100%, which is impossible. This also means that trying to estimate probabilities at the ends of the model will be inaccurate. An alternative would be creating a model that would converge to 0 or 1 rather than allowing for the possibility of a below 0 or above 100% probability. Finally, a problem with LPM is that during regression, each point is treated as if it is coming from one population of the same variance, when in reality, each one has its own independent error and has its own variance. Although LPM has its own problems, it is a tool and it does have its own use. Thanks for watching, and I hope that this video gave you a conceptual view of how LPM works.